Assalamualaikum warahmatullahi wabarakatuh. Good morning everybody. My name is Teguh Suprianto with my team, Mr. Darmansyah and Muhammad Firdaus Jauhari. The title of this presentation is Effect of Temperature on the Hydrogen and Methane-Rich Syngas from Slow Pyrolysis of Meranti or Surya wood. One of the effective ways to produce alternative fuels through biomass is pyrolysis. In this study, the pyrolysis process was used to produce syngas from sawdust from Meranti wood. This wood is one of the typical woods in Kalimantan. So this is one of the main material for house building in Kalimantan. And biomass from sawdust can be used as energy resources. So this is experiment is to investigate the using sawdust from Meranti as fuel. About this research intends to investigate hydrogen and methane content in synthetic gas or syngas produced by pyrolysis of Surya wood. This is our experiment setup. We are using the LPG flame to heating biomass in the pyrolysis reactor. We use fixed bed reactor to pyrolyze biomass from sawdust. The gas from pyrolysis flow through pipe and cooled by ice bed, and the gas flow through gas sensor, and then gas sensor detect the hydrogen and methane content, so we can use data from the sensor to make analysis. This is the heating rate of the pyrolysis. The pyrolysis temperature was carried out at 200 degrees until 400 degrees with a constant flame for 1 hour. This is the heating rate. The temperature heating rate is very rapid in the beginning and then getting slow at temperature above 300 degrees. This can occur because of the heat loss from the reactor. This is the result from our experiment. We can see that there is two peak of the hydrogen gas content in the synthetic gas occurred twice at a temperature of 230 degrees and 370 degrees respectively. This can be occurs because the hemicellulose and decomposition occurs at 220 degrees until 315 degrees, while cellulose takes place in the temperature range of 306 and 15 until 400 degrees. Lignin decomposition occurs slowly from 300 degrees until the 900 degrees. From this experiment, we can show that at the temperature of 230, the hydrogen content is very rapid produced. So it can be concluded that at this temperature, hydrogen content resulting from the decomposition of hemicellulose. And then at the 370, it is the second of peak produced hydrogen, and it can be resulting from decomposition of cellulose. And then it is the methane production from the pyrolysis. We can see that the methane concentration is show that the peak of methane gas content in the syngas occurred 2 times of peak production. The first time is at the 220 degrees, and the second time at the 370 degrees. At the first time of the decomposition, can be resulting from the decomposition of hemicellulose, and at the second time, or it is at the 370 degrees, it can be occurred from the result of the decomposition of the cellulose. Conclusion: the peak of hydrogen and methane gas content in the synthetic gas from slow pyrolysis of soya wood occurred twice at temperature of 260 degrees and 387 degrees. Different decomposition of the cellulose, hemicellulose, and lignin component in the biomass affecting production of the hydrogen and methane. The high gas content of hydrogen and methane in the synthetic gas produced from the pyrolysis process was 2006 part per million, and the methane is to 107,000 part per million respectively. Okay, thank you very much. Thank you for Dirjen Pendidikan Vokasi, Kementerian Pendidikan, Kebudayaan Riset and Teknologi has founding this research. Wassalamualaikum warahmatullahi wabarakatuh.